Okay, so for day 3, we're going to be looking at properties of limits, and then we're going to look at limits of exponentials. So first thing for this first part, we're just going to write down the properties. So this tells us that if the limit as x approaches a of f of x, we're going to assume that is equal to some number L. And then the limit as x approaches a of g of x is going to be equal to some number m. So these are properties. So this says if the limit as x approaches a of f of x plus g of x, well, the property says that you can split these into two separate limits. So the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So that means the same thing. So that's going to be equal to, because we know the limit as x approaches a of f of x is L, plus we know the limit as x approaches a of g is m, so that's equal to you just adding those numbers L plus m together. So these three things all mean the same thing. Okay. So then for number 2, this is the limit as x approaches a of f of x minus g of x. So we can separate that into the limit as x approaches a of f of x minus the limit as x approaches a of g of x. And because we know that this limit as it approaches f of x is L, then we have minus in the middle, and we know the limit as x approaches a of g of x is m, which is the same thing as L minus m. Okay? And we're going to see how all these properties work with actual problems in a minute. So then the next one we have is just division. So we can separate it just like the other one. So the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. Okay, well we know the limit as x approaches a of f of x is L divided by the limit x approaches a of g of x is m, so it's the same thing as L over m. So it's the same thing as dividing those two numbers. Same thing works with multiplication, so we can split those up. So the limit as x approaches a of f of x times the limit as x approaches a of g of x. So because of what these are equal to, we know this is the same thing as L times m. So pretty much for addition, subtraction, division, or multiplication, if you have multiple limits here, you can break them apart, and then whatever their solutions are, you can either multiply those together or whatever the operation is. So then a few more properties. So looking at number 5, the limit as x approaches a of c, and c is just a constant here, so like the number 5 or something, times f of x. Well, what you can do here is you can rewrite it as two separate limits. So the limit as x approaches a just of c times the limit as x approaches a of f of x. We'll see this in a second, but when you find the limit of just a constant, so the limit of 5, there's nowhere for you to plug it in, so it just has to be that number. So the c is going to stay. So it would be just be c times, and we know this limit is L. Okay, so once again, c is just a constant. So then for number 6, we have an exponent here. So this is the same thing as raising the whole limit. So the limit as x approaches a of f of x, raising whatever that whole limit is to that power. So that's going to be the same thing as saying L to the p power. And then the last one for number 7, we kind of mentioned it above. So the limit as x approaches a of a constant will always just be whatever the constant is, because there's nowhere to plug it in to do direct substitution. Also, if it was a constant line, the y value would always be what that c value is, no matter where you go. Okay, so those are the properties. And now we're going to look at how we find these properties. So we have some graphs to look at. And I cut and pasted this, so I hope it'll be easier to see. So for our first example here, it says the limit as x approaches -2 from the left of f of x plus g of x. So what we're going to do here is, first off, we need to rewrite this as two separate limits to show that you know the notation. Okay, because remember, you're going to have a lot of free response type questions, and you have to show all your work. So you got to show all your steps. So this is the same thing as saying the limit as x approaches 2 from the left of f of x plus the limit as x approaches 2 from the left of g of x. So we're going to use the graphs. Just make sure you pay attention. This is f of x, this is g of x. So if we want to do the limit as x approaches 2 from the left of f of x, and that's going to be that y value of 3. And then we have the plus. And then the limit as x approaches 2 from the left on g of x, well here's 2. If we come in from the left, that y value is 1. So now you can add the 3 plus 1, and the answer to this will be 4. So you just have to make sure you show that you know how to rewrite it. And then once you rewrite it, you just break it into individual problems, and then you can add their answers. Okay. So for the one beside of this, we need to rewrite it first. So because we have these constants, I would bring the constants out front. So I can rewrite this as 2 times the limit as x approaches negative 1 of f of x. And then minus, bring out your 3, the limit as x approaches negative 1 of g of x. Okay, so when you're doing this, that 2 is just going to stay. We just need to figure out the limit as x approaches negative 1 of f of x. So here's negative 1. Make sure you check the left and the right. Well, at the left and the right, it's come to that negative 6. So 2 times negative 6. Then we have minus that 3. And now we got to figure out the limit as x approaches negative 1 on g of x. Well, here's negative 1. The left and the right are the same, and that y value is negative 1. So this will give us negative 12 plus 3, so we end up with negative 9. Alright, so next one beside of that, the limit as x approaches negative 3 of f of x minus g of x, so we want to write them as separate limits first. Okay, so then we're going to figure out the limits. So the limit as x approaches negative 3 of f of x, so if you come in from the left and you come in from the right, it's approaching that y value of negative 2. We have the minus sign. And then for g of x at negative 3, well, if you come in from the left, it's infinity. If you come in from the right, it's negative infinity. And there's a vertical asymptote there, so remember that limit doesn't exist. So if one of these does not exist, that means the whole thing doesn't exist. Okay, so we need to write that this is does not exist. And we're going to say because the limit as x approaches negative 3 of g of x doesn't exist. Okay, you can't add something together that does not exist, so you have to break that apart. Alright, so the next one underneath it, I'm just going to move this over here. Okay, so the next one we have is division. So the limit as x approaches negative 2 of f of x over g of x. So I'm going to bring the negative 2 out front. We'll say negative 2 times the limit as x approaches 6 of f of x over the limit as x approaches 6 of g of x. They're going to end up with negative 2 times, we've got to figure out the limit as x approaches 6 for f of x. Well, when you come in from the left and the right, that both gives you that y value of negative 4. Okay, and then in the denominator, we're doing the limit as x approaches 6 for g of x. So as you come in from the left and you come in from the right, it's approaching a y value of 6. So we're going to end up with 8 over 6, or 4/3. Alright, so the next one, we have this constant 2 that we can bring out front. So this is the same thing as 2 times the limit as x approaches 4 of f of x times the limit as x approaches 4 of g of x. So equals 2. We need to figure out the limit of f of x as x approaches 4. So here's 4. As you come in from the left and you come in from the right, they're both approaching -3. And then we're going to do the limit as x approaches 4 for g of x. So as you come in from the left and the right, it approaches that y value of 4. So we're going to have -24. And then for the next one, we have this exponent. So remember with exponents, you can rewrite it as the whole limit raised to that exponent. So we just need to find the limit as x approaches -2 on f of x. So here's -2. As you come in from the left and the right, they both approach -5. So this is the same thing as saying -5 squared, which is going to give us 25. Alright. So then for this last 3 here, we have the limit as x approaches 2 from the right. Now it is underneath the square root, so I'm going to do a couple things. First I'm going to bring this 2 out front. And then you don't have to rewrite it like this. You could put the square root over this whole thing, but remember the square root is the same thing as 2 to the 1/2 power. So you could rewrite it like that. So either way, or you could put a square root around it. It's the same thing. So we need to figure out the limit as x approaches 2 from the right. We're on g of x. So 2 from the right is coming towards that 6 there. So this is the same thing as 2 times 6 to the 1/2, or 12 to the 1/2. So we could also write that as a square root of 12. So just know you could have kept that square root, or you can change to that 1/2 power. Either way is fine. Okay, so this one we have just division. The limit as x approaches 2 from the right of f of x over the limit as x approaches 2 from the right of g of x. So 2 from the right for f of x is going to get us to that -2. And 2 from the right on g of x is going to get us to that 6. So we're going to end up with -1/3. Okay, and then the last one we just have is subtraction. Okay, so if we do the limit as x approaches -1 on f of x, so from the left and the right it's approaching -6. And we have minus. And then for g of x, as x approaches -1, the left and the right is approaching -1. So we're going to end up with -5. Okay, so that's how the properties are used with your limits, looking at the graph.